Okay, here's some examples of rational expressions in dividing. And remember, we really don't know how to divide fractions. We only know how to multiply. So we use this little trick, and the justification for this is probably fairly complicated. So if we've got this fraction divided by this fraction, all right, this would be the dividend, and this would be the divisor. Then what we would do is we invert the divisor. Invert and multiply. And we flip it, and it accomplishes the same thing. And you can think of this as saying 10 divided by 2 is the same thing as 10 times 1/2. It's a nice example. 10 divided by 2 is the same thing as 10 times 1/2. Both cases you get 5. So that's not really a justification, it's kind of an example of how it works. So what I did was, this was the original problem, so I just inverted the divisor and then I multiplied. And again, we just have to factor. Remember, that's our main word: factor, factor, factor. And we're going to have products of binomials in all cases. So it's pretty much going to look like this. Let's move this up a little bit so you can see it a little better. There we go. All right. And we're going to have x's in all these spots. So these problems are usually designed so you get the chance to really review your factoring. Okay, so here this tells me these signs are going to be different. These are the simple trinomial, difference of perfect squares, simple trinomial. And you want to be able to identify by names the factoring methods we're using. And we try to stay consistent with that. So this tells me these signs are going to be different. The sign of large will be negative, so I analyze my signs first. Negative, positive, multiply to get 5, differ by 4, 5, and 1. See? And check it. Negative 5x plus 1x is negative 4x. Negative 5 times 1 is negative 5. And over here, this tells me the signs are going to be the same. They're both going to be negative. And the only way I can get 2 is 2 and 1. And that better check out. Negative 2 and negative 1 is negative 3. And negative 2 times negative 1 is positive 2. And over here, I got the difference of perfect squares. X and 2 are the square roots. So x plus 2, x minus 2. And over here, the signs are different. These signs are different. This tells me the sign of larger is negative. So negative, positive. Multiply to give 10, differ by 3, be 5 and 2. And negative 5 plus 2 is negative 3. Negative 5 times 2 is negative 10, so that checks out. So there's your factored form. And then we just, like I say, simplify by simplifying any top with any bottom factors that are the same. So we've got, do we have any x minus 5s in the bottom? Sure, there's one over there. Do I have any x plus 1s in the bottom? No. Do I have any x plus 2s in the bottom? Yes, I do. Right over here. Do I have any x minus 2s in the bottom? Yep, there's an x minus 2 there, so that's what we got. So this is what's left. X plus 1 over x minus 1. Now, if you're asked for the restrictions on the domain, it's any values that ever make a denominator 0. So I'll just do this one. X cannot equal. And remember when we started here, this was in the denominator. And this was in the denominator. So this still is in the denominator, but this is up in the numerator. But these values still are values we can't have. All right? It kind of works out okay for this one because we also have plus or minus 2. But since I have a plus or minus 2, this was originally in the denominator. X cannot be plus or minus 2. All right? But in this particular case, it worked out because it's also in the denominators of my finished product. But if it was different, you'd always have to check that. So x cannot equal plus or minus 2. If any place in the problem you see you can't have a value that will make the denominator 0, even before you invert. Okay, and then x cannot be, so plus or minus 2, that takes care of these also. And then negative, well, 1 and 5. Because if I have 1 minus 1 or 5 minus 5, so it cannot equal 1, 5. So those are restrictions on the domain, so keep that in mind. Okay. Number 9. Okay, number 9, again, this was the original problem, so we had to invert the divisor and multiply. And then we'll just have to factor this guy out here. And again, we've got actually 4 simple trinomials, which is one of our favorite factoring methods. We should get pretty good at these. All right, this tells me these signs are different. Sign large is negative, so negative, positive. Only way I can get 3 is 3 and 1, so that should check out. Negative 3x plus 1 is negative 2x, and negative 3. So we always check the middle and the last terms. Signs are, this tells me these signs are going to be different. Sign large is negative, so negative, positive, and 2 and 1. Only way I can get 2, and that's negative x, negative 2x plus x is negative x, negative 2. Signs are going to be different. Sign large is positive, positive, negative. Multiply to give 6, different by 1, 3 and 2. That checks out. And finally, the signs are different. Sign large is positive, negative. And multiplies to give 15. How about 5 and 3? They differ by 2. Oops, 3. Excuse me. So 5x minus 3x is 2x, and positive 5 times negative 3 is negative 15. So there we go. So we got it factored. So again, cancel any common top with any common bottom. Do I have any x minus 3's on the bottom? Sure, there's 1 down there. Do I have any x plus 1's on the bottom? Yep, there's 1 there. Any x plus 3's on the bottom? No. Any x minus 2's on the bottom? Yes, there's an x minus 2 over here. So, and that's it. So this equals, all I have left is x plus 3 on the top, and all I have left is x plus 5 on the bottom. And then you got all the restrictions on your domain. X cannot equal, so we got negative 2 on the bottom. And now remember, this originally was in the bottom over here, right? If we look at this originally was in the bottom and it's up in the top. So since it was in the bottom here, we've got restrictions here. So x cannot be 3 or, I'm sorry, x cannot be negative 3 or 2, and it cannot be 3 or negative 2. I'm sorry, can't be 3 or negative 3, and it can't be 2. So it cannot be plus or minus 3. Let's take care of that first, because that takes care of this. It cannot be 2. That would take care of both cases, because this was originally the bottom, so it cannot be 2. And it cannot be negative 1 or negative 5. That should take care of any time we have a factor of 0 in the denominator. So over here we had, this was originally the bottom, so this would be negative, can't be negative 3 and can't be 2, so that's covered there. And then over here, can't be 2, that's covered. Can't be negative 1, that's covered. Can't be 3, that's covered. And can't be negative 5, that's covered. So that covers all my restrictions. Anytime in the problem, you cannot have a value of x that makes it a denominator 0. Okay, and then the last one, number 10. This is kind of a combination of multiplication and division. And we just have to invert whatever's to the right of the division sign and change it to a multiplication sign. So this term stays the same, this factor stays the same, this factor stays the same, and this factor we flip or invert. And then, like I told you before, the easiest way to deal with these, or the safest way, is to write them out in factored form. So 4 is 2 times 2, and then I got 4x's, x times x times x times x, all over 6, which is 3 times 2, and then y times y. Oops, I'm sorry, xy, excuse me. Kind of looked at the other factor, pardon me. So I got my white out here. So that's just x times y. The only thing is it takes a little room here. So. And then I've got x cubed, x times x times x, all over 3 times 2, that's 6, and then y times y. And then finally 12, which is 2 times 2 times 3, that's 4 times 3 is 12, and then I got 5 y's. 1, 2, 3, 4, 5 y's. All over 5, that's already a prime number, and then x times x. So I factored all these out. Now you don't have to do this. This is just the easiest way for me to explain it. So my 2's, 2 over 2 is 1. Don't have any more 2's on the bottom. I got a 3 over here, so these 3's can become 1 or reduce. And then I've got a couple x's here, so x, x, and that'll take care of these 2 x's. And then I got some y's over here. Take care of those 2 y's, and then I got another y down here. And I think that's up another x over here, in the top over here, so let me do that over here. So there we go. Alrighty, and what's left? Well, on the top I've got 2, 2, 2, so 2 times 2 is 4 times 2 is 8. So on the top I've got 8. And then I've got x, 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 so I got x to the 4th, 4 x's. And I've got y squared. And on the bottom I have just 5. So there you go. So if that makes sense. X, x, y, y. Yeah, 4 x's. 4 x's in the top, 2 y's. So hopefully everything's fine on that one.